A good day to everyone who's watching. In our lesson today, we're going to talk about the equations involving logarithms. So our example 1, solve the equation log of that minus log of that is equal to a 1. Now, we have alternatives in mathematics. So the first alternative is for you to make every term that is in the equation to be having a log to the given base. So the base here given is base 10 because it's not there, but it is base 10. So we must make that one log base 10 also. And remember, from our laws of logarithm, we said that log of a number to any base, that one condenses to 1. So I'm going to substitute the 1 for log 10 base 10. If they had used log base 3, you substitute log 3 base 3. After making every term in the equation to have log base 10, now on the left hand side there are two terms there, and the sign in between them is a minus. So I'm going to write it as a single log. So we said if it is a minus, we get that value there, divide by that value. So log of 7x plus 2 divide by x minus a 1 there. So this one here is going to be equal to log of 10 base 10. So when I reach here, I'm having one term this side and also one term the other side. All of them, they are logarithm to the same base. So that means that the value which is here is equivalent to the 10 there. That is my 7x, my plus 2, all over x minus 1 is equivalent to 10. So when you reach there and you see that you have log to base to the same base, then the value which is there is the same as, but only if you have single logarithm either side. One logarithm either side. So coming back here, this 10 is all over 1, and then cross multiplying, that's going to be 7x plus 2 is equal to 10 into x minus 1. So from here, I can simplify, open the brackets the other side, that's going to be 10x minus 10. This side is 7x plus 2. Then collecting like terms, take 7x the other side, becomes a minus. Then bringing the minus 10 this side, it becomes a positive. And then the 2 was also positive. Here, this side I get 12 is equivalent to. The other side, when I subtract, I have 3x. So then that is my 3x is equivalent to a 12. Then I divide this side by 3 and also this side by 3. I get my value of x as a 4 there. Another way, when you reach here, you have written the other side, the left hand side, as a single log, and there is a 1 there. You recall the index format of writing log. Remember, we said log of a number is the power of the base, that if I have 2 power 3 is equal to 8, this is the index form, but in logarithmic form, this is log of 8 base 2 is equal to a 3. So you come back here, you identify where is my 2, where is my 3, where is my 8. So this is what we have there. The 8 is the whole of that. So when I try to write it, this is going to be 7x plus 2 divided by x minus 1 is equal to, the 2 here is the base. So the base here is 10. Then the 3 here is the log of this number here. So this is the number. Then I raise it to the base. So 10 power 1 is the 10 is equal to 7 plus 2, 7x plus 2 divided by x minus 1. And to go back to the other previous step, here you cross multiply and then you continue. Example 2, solve the equation. That one there. So what I'm going to do, this left hand side, since there is an addition, I'm going to write it as a single log. That is my log of x times 5x. The base is still the same, is equivalent to a third. So when I multiply there, I have log of 5x squared base 1 to 5 is equal to a third. Now, I'm going to write it in index form now, recalling my log of 8 base 2. This one is 3. So index form, this is 8 is equal to 2 power 3 there. Comparing this with what I have here, this one here is my 8, 5x squared is equivalent to the base here is 1 to 5 power that one there, which is a third. Now, you recall in index form that the power third is the same as the cube root. So what is now the cube root of 1 to 5? When you place on your carry, the cube root, I have the cube root as 5. Then I divide both sides by 5 because my aim is to get the value of x. So x squared is equivalent to a 1. Now, to get my value of 1x, I take the square root, both sides. So x becomes plus or minus 1. Our example 3 there, they have told us to solve the equation. All of the terms there, they are having log to a uniform base, which is base 10. So my aim is to see that both sides, my aim is to see that both sides I'm having single logarithm. Then thereafter, I equate the two. So on the right hand side, I'm going to first take back this there because I cannot write a single logarithm if there is a value there. So this is log x minus 2, then plus log of 2 power 3, then log of 3x plus 4 is equal to the log of x minus 2, then plus log of 8 after cubing that. Then now there is a plus here. I'm going to multiply these two. So the other side, I'm having log of 8 times x minus 2 base 10. This side, I'm having log of 3x plus 4. Then now, I'm going to equate this to that because I'm having single log either side, and then the base is also the same. So this is 3x plus 4 is equal to 8 into x minus 2. Opening brackets this side, I'm having 8x minus 16. Then this side, I'm having 3x plus 4. Now collecting like terms, I take the 3 the other side to become a negative. Then the minus 16, I bring it this side to become a positive. So when I add this side, I'm having a 20. When I subtract that side, I'm having 5x. Then when I divide both sides by 5, I get my x value as a 4. Example 4, find the value of m if 2 power m is equal to 5. So remember, in index numbers, we said that you express the other side as the same base as this one. Now here you cannot express 5 as a base of 2, or you cannot prime decompose 5 to have 2 to power something. So what we do, we introduce logarithm there. Why introduce logarithm? We are aiming at moving the power up there. We bring it in the numerator. So introducing log base 10, because on our calculators we have log base 10 there. Introducing log base 10 both sides. Then this power is going to somersault there. So this is going to be m times log of 2 is equal to log base 5. So now you can easily see that we can divide both sides by log base 2 and log base 2 to get the value of m there. So my m, to leave it alone, I'm going to divide both sides. Then this one is going to be equal to m is equivalent to log of 5 base 10 divided by log of 2 base 10. So you get your calc, you open brackets, feed in log 5, you close brackets, divide by, open brackets, log 2, you close brackets there. So when I divide, I get 2.322 as the answer on the calc.